Alright, so this is systems of equations. Okay, and there's three ways to solve them, so I'm going to give you an example of each. Something to keep in mind, solving a system of equation is finding the point or points of intersection. So this is all happening graphically, even if we solve it algebraically. So keep in mind that your answer should be written as a coordinate. Okay, that means, you know, an x comma y value. So, solve by graphing. First thing you got to do when you're graphing something is you need to plot the points. So, here, remember we've got y equals mx plus b, and you begin at the b and move with the m. So if I begin at the b, I'm going to start with my y-intercept at 3, and moving with my m, which is -1, and it goes down 1 and over 1, because rise over run is -1 over 1. If I couldn't move that way, I could go up 1 and to the left 1. But either way, it has to be a negative slope, so I know that it should be going down, and I connect it, it should look like that. Okay? And the next guy, my beginning at my b is at -3, so I'm down here, and my slope is -7. Well, on this graph, I can't go down 7 and over 1 nicely, so I'm just going to go up 1, 2, 3, 4, 5, 6, 7, and over 1. Automatically, I've crossed a similar point, so I know that that's actually going to be my answer, which is very nice. Let me make this normal writing. So this right here is my answer, and that is at -1, +4. Boom. Alright, let's check out the next guy. If I am solving with substitution, remember substituting means you're going to replace something with something else. Since this is already solved for y, substitution would be a really smart choice here. I can take this entire piece and plop it in for the y. So when I'm doing substitution with something big like this, I like to rewrite this first guy, and wherever I'm going to substitute something, I just put in a big set of parentheses, and then I take what I'm substituting and I plop it into those parentheses. For some reason, it just makes a little bit more sense. I don't get as caught up when I'm writing things, and I don't end up forgetting if you're supposed to add something afterwards. So just a little tip to help you out. So we are going to solve this. So my -2x comes down. I'm going to distribute my +3. So 3 times 3x is 9x. 3 times 17 is 51, and it equals -5. Now I can combine my like terms, which gives me 7x plus 51 equals -5. Down to a little two-stepper, subtracting 51 from both sides. So my 7x will equal -56. And when I divide by 7, I learn that my x value equals -8. So I know that my answer should be in a coordinate. I'm going to set that up for myself already. This is going to be my final answer. I've got my -8 for x. So now we can take one of our equations and we can replace x with the value that we found for it. So we know that it's a -8, and that allows us to solve for this. So my y will equal -7, and there's my answer. Okay, so that's substitution. They're substituting things in, shocking. And the last one is elimination. I love this one for some reason. So to use elimination, you literally have to eliminate something. So you want to make either your x coefficients or your y coefficients the exact same, but one being positive and one being negative. So 4 and 9, I would have to change both of them. But with 2 and 4, if I could just create something so that this was a -4y, that would work out. So I would have to multiply this entire thing. To make it a negative, I need to multiply it by a negative, and 2 times 2 gives me 4. So I'm going to have to distribute this -2 to each of these pieces. -2 times -4x is going to give me a positive 8x. 2y times my -2 is my -4y. And 4 times -2 is -8. Remember, we're going to keep emphasizing what should my final answer look like. Coordinate, coordinate, coordinate. Okay, so I'm going to set this up ahead of time so I don't lose track and figure out what I need to do. Okay, now that I've done this, I can actually add equations together. You are allowed to do that. So I'm not going to use this guy anymore. I just want these two right here. So 9x plus 8x is going to give me 17x. 4y minus 4y eliminates just like we wanted it to. Do you see what I did there? Do you see what I did there? And negative 26 minus 8 is going to give you negative 34. Then when I divide by 17, I'm going to get x equals negative 2. So there's my negative 2 value. And then just like we did in the last one, I can take either one of these equations. It does not matter which one. I have an x value, so I'm going to replace it. And I'm going to be able to figure out what y is. So I know that my x value is negative 2. And now I can multiply these together to get 8 plus 2y equals 4. Oh, that's kind of funny that it turns into the same thing. That doesn't always happen. That's just by chance. Subtract 8 from both sides, and 2y equals negative 4. And then when I divide by 2, I get that y also happens to equal negative 2, which is kind of fun. And there is my answer. Okay? So try the problem on the back on your own, and then we will chat more about it next class.